Hello, I'm Andrzej Arshavsky. I'm in charge of artificial intelligence in Gazprom neft and also work with data. So today I'll be speaking about science and practical research helping each other in AI. I'll start with this brief introduction just to stipulate what we do in Gazprom neft. We are a vertically integrated company that is about development, exploration, refining, drilling, etc. We have sizable business, quite a lot of processes are involved. There are quite a lot of processes requiring mathematical modeling and creating forecasts, what's going to happen with the all value-added chain. We've been implementing AI solutions in the company. Also in some of the areas that we consider as priority ones, that is automation of routine operations and support of the decision-making while planning of the exploration and production, refining. We are optimizing logistical tasks. We are minimizing various capital investments, etc. There are plenty of fields where AI may help us run our business and help us develop our business in the future, like previously. We work with lots and lots of data. They mainly belong to our oil-producing companies, and they have their own specifics. Most of them are seismic data provided by such companies from subsoil, and those drilling related pieces of data. When we are talking about extraction and talking about production, that's what's happening during the course of drilling. What we have taken from bore, core samples can be digitized, and reservoir layers showing what happens inside. The same principles apply for sensors data, documents, etc. There's nothing special about it. For a few years, we have been implementing solutions where AI is used. I will show you a quick example of typical tasks and show you where science needs to be involved. The simplest example may be a service that would help us improve oil production by selecting those wells where it would be expedient to apply the chemical treatment method. For example, after drilling the hole, we start pumping and recovering oil. At a certain time, the flow rate drops, so we have a practical and theoretical possibility of injecting chemicals into the well, thus improving the flow rate of the well. But sometimes it would not result in a positive outcome, and injecting chemicals is a costly operation. So we have trained random forest, classic machine learning method here, and we ended up having a pretty good forecast which will help us make this decision and spend 40% less funds on chemical treatment and improve the production flow of the wells. It's a typical solution. We are not just developing these models. We call them intellectual digital services. They are small software modules encompassing the models themselves and different contours, where we would validate the acceptability of the solution and giving recommendations to the users, etc. We combine these services into the uniform structure, which is managed through one orchestration center, is communication is conducted through the uniform bus. It's one of the things we focus, and that's where we apply our AI platform. That's our day-by-day business, which is about developing and implementing AI solutions and working with the data. But there is a class of tasks, like I've shown you, that could not be resolved that simply. There are more complex tasks that we don't have enough experience, and we don't have too many reference cases on how to resolve such problems. They are not typical, and they're very responsible, very important, and should be taken by an individual, an expert. That's up for them to decide. And we need not just to simply automate this process, but to make this process of a better quality in terms of its outcome, in terms of its effectiveness. So it would be beyond human capacity. And the modeling and simulation of reservoir that the well penetrates can be used as an example here. As we develop oil fields, we continuously keep having more data and having a comprehensive system which would actualize such models are absent right now. And training any mathematical model with a classic method to resolve that task is not possible either, because variability here is huge, and it puts a lot of constraints on it. Therefore, we think it would be necessary to invite scientific society so that we collaborate in artificial intelligence solutions. Currently, in actual fact, we are in different fields. We tackle the practical solutions, and the science deals with science, so to speak. Practical solutions used to be theory some time ago, but then they became available for the general public. And the potential to study different areas is huge. The researchers can be hired and used to tackle those tasks that cannot be resolved quickly, just simply overnight. You can jointly try and develop a new combined set of methods to tackle new and complicated cognitive tasks that they would help you in making very complex decisions. The research groups may help us fine-tune the existing solutions and bring them to the better level. So we may become much closer to the resolution of some problems that don't seem to be resolvable yet. As I stipulated, practitioners very weakly collaborate with academics, even in the A+ class conferences, where we see lots of interesting findings published. Approximately 10,000 articles a year are published. If 5 or 10% of all those articles turn into practice to improve data science's work, really, digesting all that amount of material is not quite possible. Scientists keep on doing what they do, and practitioners sometimes take a look at what they do, but very rarely. Do it very rarely. How can these studies help us help the practitioners in the production sphere? When the practitioners develop such solutions, they are not 100% certain that they have squeezed out what they wanted from the method they apply. If there is a solution having 10% efficiency improvement versus the standard one, which is used by default, if the use of the state-of-the-art approach can improve it by 3%, it may be ultimately saving you millions and millions of and the second thing is that sometimes we'd be facing the situation of the lack of data. Lots and lots of small data studies are carried out, and theory can help practice here quite significantly. The third story is about having sufficient amount of data, but not at all times we can use this data because the technology is changing. And this data which has been collected, you'll have to wait for them to come up. And they can also turn out to be useless because the technological process has changed. So working with small amounts of data and the generation and the reinforcement learning can help us quite a lot here. And yet another factor, maybe the last one that I would like to quote, is that if this solution really working, but we don't know whether this model is self-sufficient. In terms of those examples we used, maybe this model is not quite certain. So this situation would not allow us to use the forecast model with responsible situations, and a few scientific groups like Vetrov's group, they're carrying out research in that field as well. It may be very useful to apply such AI solutions in practice. Speaking in terms of research conducted worldwide, we can split them by 7 classes by this popular method, popular approach. On the one hand, these are the tasks that can help us improve the precision of the current solutions, and we may use small amounts of that data and practically having no data for that. And there would be another type of research which will help us reduce the amount of computations, thus making the resolution of a problem cheaper. Also, there are some security-related stories with the use of the artificial intelligence and the confidence about having the right result and combating the attacks versus neural networks. We know all these stories about potential attacks to neural networks. All these things help us optimize spatial modeling, increase the reliability of the decisions made, and come up to the resolution of complicated and complex tasks in no time. I've just called a number of topics that the scientists are currently working on, and that's where cooperation is encouraged. And what about this cooperation with the scientific groups? There are a few things to consider. First of all, you just set the tasks to the team. Like, for example, we have encountered a problem. There seems to be no resolution. Maybe you try, and we share this problem with you. And alternatively, we can work with some scientific groups, raise funds for them, and ask them to help us every once in a while with their solutions that are available, whether they could help us resolve our issues. Another important thing is the so-called scouting. When we look for potentially interesting publications, and when we train data scientists using that information, and this intermediary form of artificial intelligence, which I will tell you a little bit later. There's been a lot of words said about general AI. We treat this cautiously about having the existence of general AI possible, but in prospect there may be narrow AI system which would help you make complex solutions in a very narrow field, which would not be just limited by one simple model or just a few models. Even with deep learning, there may be some kind of a resolution created with the facts taken into account, with some probability approach, with some predicted models used. It may work to make decisions at approximately that level or better than experts level in a very narrow field, I repeat that. So it's a self-learning intellect, a combination of methods, a complex approach. That's important. This is what we are interested in. Also, meeting the scientific teams, trying to make these decisions more appropriate. And we have a number of such key tasks where it may be found useful, like, for example, the development of the new fields and planning of the development of the fields, oil fields. Well, we'll have to consider a lot of types of scenario, where to drill the well, where we're going to put the equipment on surface, etc. Experts are tackling such problems these days. So if we are going to apply augmented AI, which will be capable of doing such planning, it will be a great achievement, and money-wise for Gazprom neft it's going to be a real cost cutter. Another optimization of the refineries is important, where we'll be having approximately 50 chemical processes linked together, and the complex management system of such refineries with the use of the AI may give us a lot of benefits. Sometimes it's not quite possible to do that without automation. Also, the optimization of the engineering, of some engineering projects, especially in the beginning of the year, we'll have to make decisions about such projects, and we'll have to use the previous experience about similar projects. This process can be rationalized. And the final example is the ice situation. By using observation from space, monitoring from space, you know what ice making is all about. Ice in the Arctic, for example, may be of different thickness and different type, and navigation very much depends on the ice situation. If a tanker approaches a drilling platform, misses, and they will have to circle a few hundred kilometers in order to make the second move. So we have highlighted those problems. The partnership, we have 6 leading teams of the A-class types, Skoltech, and other institutions, for instance, that you can see on the slide. We have a potential. We have arranged artificial intelligence competence center, artificial intelligence in industry. I would like you to join such activities. I think more companies will be finding it interesting, so that we'll be joining Earth and the stratosphere, two flows, the development of artificial intelligence, etc. So thank you very much for listening.